let's get into problem number 3. Okay, in this third problem, a ladder is placed along a wall of a house such that its upper end is touching the top of the wall. The foot of the ladder is 2 meters away from the wall, and the ladder makes an angle of 60 degrees with the level of the ground. Find the height of the wall. So now let us assume that AB be the height of the wall. This is the ground. Okay. Now a ladder is placed along a wall of a house such that its upper end is touching the top of the wall. So the upper end of the ladder is touching the top of the wall. This is the top of the wall. So the ladder is touching the top of the wall. Okay, the foot of the ladder is 2 meters away. The foot of the ladder, this is the ladder. The foot of the ladder is 2 meters away from the wall. So it is 2 meters away from the wall. And the ladder makes an angle of 60 degree. So the ladder is making an angle of 60 degree with the level of the ground. With this level of the ground, the ladder is making an angle of 60 degree. So find the height of the wall. So you need to find the height of this wall. So let us assume that this value is x, because you are going to find the height of the wall. So while doing this, what you need to do? You have opposite side an undetermined value. You have the adjacent side, which is a finite value. Along with this, you have given the angle of elevation. So the only thing what you can do is nothing but tan of 60 degree. Tan of 60 degree will be nothing but AB opposite side by adjacent side. Let it be C. AB divided by BC. Opposite side divided by adjacent side. So opposite side is x. Adjacent side is 2 divided by 2. So x will be nothing but 2 into tan of 60 degree. So what will be tan of 60 degree? Tan of 60 degree will be root 3. So root 3 will be tan of 60 degree. Therefore 2 into tan 60 degree, that will be 2 into root 3 meters. Therefore x equal to 2 into root 3 meters. So x is equal to 2 into root 3, which is nothing but the height of the wall. This is the height of the wall. Okay, fine. So now let's get into problem number 4. Problem number 4 states that an electric pole is 10 meters high. A steel wire tied to the top of the pole is affixed at a point on the ground to keep the pole upright. If the wire makes an angle of 45 degree with the horizontal through the foot of the pole, find the wire's length. Find the wire's length or the length of the wire. So we'll go step by step. An electric pole is 10 meters high. So let us assume that this is the electric pole, which is 10 meters. And I'm naming it as A and other point as B. Let this be the ground level. Right? A steel wire is tied to the top of the pole. A steel wire is tied to the top of the pole, is affixed at a point on the ground. It is being affixed at a point on the ground. Let this point be C to keep the pole upright. If the wire makes an angle of 45 degree with the horizontal, so this is the wire, this is the horizontal, the wire is making an angle of 45 degree. It is making an angle of 45 degree. Find the wire's length or the length of the wire. So the length of the wire is nothing but AC. Let us name it as x. So we know that in this right angle triangle, sine 45 degree, sine of 45 degree is nothing but opposite side divided by hypotenuse. So we get opposite as 10 and hypotenuse is x. So what will be x? X is nothing but 10 divided by sine of 45 degree. So which is equal to 10 divided by, what is sine 45 degree? Sine 45 degree is nothing but 1 divided by root 2. So that will be nothing but 10 divided by 1 into root 2, which is nothing but 10 into root 2. So we know that root 2 value is nothing but 10 into 1.414, 14.1 meters. Therefore, the value of x, which is nothing but the length of the wire, is 14.1 meters. Okay. So let's get into problem number 5. The problem 5 states that a kite is flying at a height of 75 meters from ground level, attached to a string inclined at 60 degree to the horizontal. Find the length of the string to the nearest meter. So a kite is flying at a height of 75 meters. Let us assume that A is a kite. This kite is flying at a height of 75 meters from the ground. So let this be the ground level. So this kite is flying at a height of 75 meters. This kite, right, from the ground level, attached to a string that is inclined at 60 degree to the horizontal. So a string is attached to the ground, and a string is attached attached to a string inclined at 60 degree to the horizontal. So the string is inclined to the horizontal. So the angle of inclination is nothing but 60 degree. 60 degree to the horizontal. This is the horizontal, right? Find the length of the string to the nearest meter. They are asking you to find the length of this string. So now this height is nothing but 75 meters. So I'm going to rub this one. So this is 75 meters. So this is the angle of inclination is nothing but 60 degree. That is, the angle of inclination is nothing but the angle which the string makes with the horizontal level of the ground. Okay, here A is a point where the kite is flying. So let us mark the points as A, B and C. So now what they are asking is, they are asking you to find the length of the string. So this portion, so AC, let us assume that this portion is X. So now what you need to do, you have this opposite side, you have this hypotenuse, and you also have the angle of inclination that is given as 60 degree. So let's use sine of 60 degree. So sine of 60 degree will be equal to this opposite side. Opposite side is nothing but 75 divided by hypotenuse. Hypotenuse is x. So x will be equal to 75 divided by sine of 60 degree. So what is sine of 60 degree? So it is 0, half, 1 by root 2, root 3 by 2. So root 3 by 2 is sine 60 degree. So 75 divided by root of 3 by 2. Okay, so this will be equal to 75 into 2 divided by root 3. So this value will be 2 5s are 10, 1 2 7s are 14, 15, 150 divided by root 3. Or you can even write as 150. So what will be the value of root 3? The value of root 3 is 1.732. It's nothing but 86.60. 86.60, which is nothing but 87 meters. 87 meters. So therefore x equal to 87 meters, which is nothing but the length of the string. So now let us get into problem number 6. So the problem number 6 states that a ladder 15 meter long just reaches the top of a vertical wall. If the ladder makes an angle of 60 degree with the wall, find the height of the wall. So you have a wall, you also have a ladder, and this is the ground level. So let us assume that A, B, C be the right angle triangle. So a ladder of 15 meter long just reaches the top of a vertical wall. So this is a ladder. The ladder is nothing but it is 15 meters long. It reaches the top of a vertical wall. This is a vertical wall. If the ladder makes an angle, makes 60 degree with the wall. So now the ladder is making, this is wall. The ladder is making 60 degree with the wall. So now in the previous problem you had the angle over here. Now this ladder is making an angle with the wall and not with the horizontal level of the ground. So it is making an angle of 60 degree with the wall. So this angle will be 60 degree with the wall. Find the height of the wall. So you need to find this by height of the wall. Let us assume the height of the wall be x. So now you have the hypotenuse value, you have the x value, and you don't have this value. So in this right angle triangle, you need to see this is the hypotenuse, this is the adjacent side, and this is the opposite side. So you have adjacent side, you have the hypotenuse, and you also have the angle value. So you need to put cos. What will be cos of 60 degree? Cos of 60 degree is nothing but adjacent side divided by hypotenuse. So adjacent side is nothing but x divided by hypotenuse is nothing but 15 meters. So x will be equal to 15 into cos of 60 degree. So which is nothing but 15 into cos 60 degree. What is cos 60 degree? Cos 60 degree is nothing but root 3 by 2. See, it will be cos 60 degree will be half. Cos of 60 degree will be 1 by 2. So 15 into 1 divided by 2, which is nothing but 15 divided by 2, which is equal to 7.5 meters. Therefore, x is nothing but the height of the wall. Height of the wall is nothing but 7.5 meters. So let's get into problem number 7. The problem number 7 states that a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff. At a point on the plane 70 meters away from the tower, an observer notices that the angles of elevation of the top and bottom of the flagstaff are 60 degree and 45 degree. Find the height of the flagstaff and that of the tower. So what you need to do is a vertical tower. Let us assume that AB is a vertical tower. This AB be the vertical tower. So let us assume that this is the ground level. So AB is a vertical tower, stands on a horizontal plane. This tower stands on a horizontal plane and is surmounted by a vertical flagstaff. Here it is surmounted. So another flagstaff is here. This is the flagpole. The flagstaff is here. So let us assume this point as C. So vertical flagstaff, okay, is surmounted by a vertical flagstaff. The flagstaff, let the flagstaff be CA. So it is being surmounted at a point on the plane. So this is a point on the plane, 70 meters away from the tower. This is the tower. So 70 meters away from the tower. Okay, 70 meters away from the tower, an observer notices that the angle of here the observer stands. The observer is noticing that the angles of elevation, the angle of elevation of the top and bottom of the flagstaff, angle of elevation of the top of this flagstaff and bottom of the flagstaff. This is the bottom. So bottom of the flagstaff are, this will be 60 degree and this one will be 45 degree. So you need to find the height of the flagstaff and that of the tower. You need to find the height of CA as well as AB. So what you need to do is, first thing is, let us consider this main triangle. Let it be M. So let us consider the main triangle CBM. If you consider triangle CBM, it will be nothing like, it will be CBM. So what is CBM? You need to find, let us assume the height of the flagstaff be X and the height of the tower, vertical tower be Y. So you have this value, you have this value. So you have this angle. So opposite side as well as adjacent side you have. So what is tan 60 in triangle CBM? Tan of 60 degree. So tan of 60 degree is nothing but this height and this height, opposite by adjacent side. So it will be x plus y divided by 70. So we know that tan 60 degree is nothing but root 3. Root 3 is equal to x plus y divided by 70, which implies x plus y is equal to 70 into root 3. X plus y equal to 70 into root 3. Similarly, again, you need to consider this triangle ABM. Consider triangle ABM. If you consider this triangle ABM, tan of 45 degree, tan of 45 degree is equal to opposite side by adjacent side. So that will be y divided by 70. So it will be y divided by 70. So we know that tan 45 degree is equal to 1. So y is nothing, which implies y equal to 70. So this value we have obtained, y is equal to 70. So we need x value. So we already have y equal to 70. Why don't we substitute this value in this equation? Let us assume that this is equation number 1. So it will be x plus y equal to 70 root 3. Therefore, x plus, we know y equal to 70 is equal to 70 of root 3. Therefore, x is nothing but 70 root 3 minus 70, which is nothing but 70 into root 3 minus 1. X value is 70 into root 3 minus 1. We have y value as y equal to 70. So what we can do is 70 into root 3 value is nothing but 1.732 minus 1. So this will be 70 into 1.732 minus 1 will be 0.732. 0.732. We get 51.24. 51.24 meters. Y is equal to 70 meters. So x is nothing but 51.24 meters. We have y equal to 70 meters. They are asking you to find the height of the flagstaff and that of the tower. Therefore, height of the flagstaff is nothing but x, which is equal to 51.24 meters, and height of the tower is nothing but y, which is equal to 70 meters. So we have found the height of the flagstaff, which is 51.24, and height of the tower as 70 meters.